Unit 8, 8.1, we're going to talk about functions, domain, and range. So first of all, what is a function? Well, to answer that, we are going to take a trip to the store. So at the grocery store, we're going to buy some items. We are going to buy some peanut butter. And when I get to the register, they're gonna scan it and it's gonna come up $4. So we say that peanut butter maps to $4. That's how much it costs. We're making a map, peanut butter, this is the cost. There we go. Mountain Dew, when the cashier scans that, beep, it comes up, costs $1. Getting some pork and beans, scan that, beep, it's $1 as well. And then some Rogaine. Rogaine's expensive. It costs, beep, $22. Okay? These items on the left side, those are called your input. You can think of those as that's what you're putting in your cart. These numbers over here, they're called the output. That's what the register displays. That's what it puts out on the display, how much it costs. Now, what would happen if one time when you scan pork and beans, it comes up as $1, but the next time the cashier scans the exact same thing, same size, same product, it comes up $12. Beep. That'd be a problem, right? If I'm buying an item, it better cost the same amount as the person that bought it before me. I don't want to pay more. Otherwise, their system would be broken. Okay? So, we want to get rid of that. We don't want that to happen. We want each item to always cost the same amount. Now, granted, there could be a sale or something. We're not talking about that. We're talking about scan it once right away, scan it again, and you get two different prices. Okay? So looking at the way we had it at first, is it okay if your output has more than one input? Yeah, that's okay. You can have two items that cost the same amount. Think about if you go to the dollar store. Everything costs $1. That's allowed. You can have that. But what you can't have is one item costing two different amounts. So you've got one input value going to two different output values. That's what we don't want. So some vocabulary here. What is a function? It's a relation, a correspondence. That's what we have here. We're relating items to their costs. So it creates a correspondence between two sets, x and y. Here's my x's over here. Here's my y's, input and output, in which each element of x is matched to one and only one element of y. Whoops, wrong way. So each thing in x can only be paired up with one thing in y. Okay, so this cannot be there. Each x goes to only one y. We don't care if the y's repeat, that's okay. But each thing in your cart can only have one price. The set x, which we sometimes call the input, the other name for that, domain. So fill that in over here. It's also, in addition to being referred to as the input, you can also call it the domain. The set y, the values over there that you're mapping to, those are called, besides the output, the range. It's the range of values of the prices. Okay, so some good vocabulary there. In terms of x and y, your definition for function, each x value can only have one y value. That's what we're saying. Each x can only have one y. However, keep in mind, having the same y value for multiple x values is okay, meaning you could have more than one thing costing the same amount. But you can't have an item that costs two different amounts. Okay, so notation. This is getting us into function notation. So notice they put an F out front. That F out front, guess what it stands for? Function. So they're saying, what's the function of peanut butter? What's F of peanut butter? That's how you say that. Well, in other words, how much does peanut butter cost? When peanut butter is the input, what's the output? It's $4. Okay, so F of peanut butter equals $4. Well, then what's F of beans? Beans is my input. What does it map to? How much does it cost? $1. Okay. Now this is kind of going the opposite way. It's saying we took the function of something and we got out 1. So over here, we had an input and we were solving for the output. But now we have the output. What could we buy that costs $1? What could we input to get an output of $1? Well, if I look at my dollar on the output, I have 2 inputs. So I actually have 2 answers for that. I have Mountain Dew, but I also have X equals the pork and beans. Okay, pause the video. You guys try these next 2. Well, f of a equals 4, that's kind of just like this one up here, the opposite way. They gave us the $4, we have to come up with a peanut butter. And then f of w, by the way, the x, a, w, those variables don't matter. W equals, what costs $12? Well, once we made it the function, nothing. So we could say no solution. Nothing costs $12. All right, let's go through some examples. Are the following correspondences, another word for correspondences is relations. Basically, do we have functions? Does each x value only have one y value? That's what we're being asked. If it does, if it is a function, give the domain and range. And if it's not a function, tell us why not. Okay, well, I've got a bunch of ordered pairs. Sometimes it's really nice to make what we just did with the store example called a mapping, and then you can see it really nicely. So if I want to make a mapping, I want to put all my x's, I want to list them. And if you want to be really good, put them in numerical order. So 2, 3, 4, 5. And then list all your y values, your outputs. 2, 5. Now I've got 5 twice. 5 is just 5, so I'm not going to write it again. I've already taken care of the 5. Now let's map them. 3 goes to 5. 4 is paired up with 5. 2 is paired with 7. And 5 goes to 2. Okay? Do we have a function? Does each x value have one and only one y value? In other words, does each item at the store only have one price? Think about that. Yeah, that's a function. 2 items both cost $5, or 2 x values each go to 5, but that's okay. More than one item could cost $5. That's totally fine. Okay. Now they ask us to find f of 5. Is 5 here your input or your output? If it's in parentheses right here, that is your input. So if I put 5 in other words, an x value, what is the y value? Well, here's my x is 5, y is 2. Now this is second one's the opposite way. Solve for x if f of x equals 5. So now they're giving us the y value. Okay? So when you're in function notation, you're thinking of it this way. F of some input gives you an output. Okay, so if they give you the part over here, that's the output. They've given us the 5 as the output. What would be the input? Well, then x has to equal, here's where 5 is my output. Oh, I've got two different answers then. X equals 3 and also x equals 4. Okay. Domain, what did we say a domain is? Well, right back here, it's all your x values, your inputs. So we're just going to list them. We're going to put them in some nice curly brackets and list them numerical order. It's kind of nice. 2, 3, 4, and 5. And your range is your y values. So 2, 5, and 7. And there you go. Okay, example 2 is really similar, just instead of them giving us the list of ordered pairs, they gave it to us in a t-chart. Pause the video, go ahead and try it. F of 2, 2 is your input, your output 6, right here. Solve for x if f of x equals 2. Now 2 is your output. Look at the difference between those. Input, output. So when 2 is your output, it's your y value. Your input was 4. Domain, just list your numbers. Keeping in mind, numerical order is nice. And if something's in there twice, you don't have to write it twice because you wrote it once, it's there. And then range -1, 2, 3, and 6. Hopefully you did pretty good on that one. All right, number 3. Okay, they didn't give us ordered pairs. They didn't even give us a t-chart. All they gave us was an equation, so it's a little different. They didn't give us a big list of values. They ask us to find f of -2. Well, remember, this -2 still represents an x value. So what do you think we could do with that to find the y? And this might be a really good time to tell you that if you see f of x, that's the same thing as y. So we've been used to seeing equations written like y equals 2x plus 5. And all we do now is we change it to f of x equals 2x plus 5. F of x and y are the same thing. Because this means you have a function that has an x value in it, 2x plus 5. Function is 2x plus 5. It's got the x in it. It's just a different name. Then a problem like this is just saying, hey, take -2 and plug it in for the x value. So you put it in right here, but then you're also putting it in for the x on the right side. So 2 times -2 plus 5, well, that would be -4 plus 5, which is +1. So there's your answer. So we used to do problems way back at the beginning of the year that would say, you know, here's an equation, let x equal -2, substitute, simplify it. It's doing the exact same thing. The big mistake that I sometimes see students make is they'll drop this f -2 down each time, which is totally fine. That would be fine right there. But then what they'll do is they'll say, oh, I must have to solve for f. Let me divide by -2. Wrong. Don't do it. This is not multiplication parentheses. This is f of, meaning we had a function, we plugged in -2. Don't try to do division there. That's crazy. That is not what it means. If I see you do that, I know you have not practiced, you have not studied, you did not watch the video. Do not do division here. This is your answer. You're done. You plug -2 in, your output is 1. That's all that statement means. I had a function, I plugged -2 into it, and I got 1 out. So that's why function notation is nicer than just using y equals, because if I did that here, I would just get y equals 1. But when I do it with this notation, I know exactly what I plugged in. I plugged in -2. Whereas this problem, I wouldn't have known that. Okay, solve for x if f of x equals 5. Well, now they're giving us the y value. and they want us to find the x value. Well, if your y value is 5, f of x equals 5, you're not going to plug it in for the x value. You're going to plug it in over here. Be careful, though. It's not f of 5. This whole thing, this whole f of x becomes 5. Okay, I'm going to erase this just so I can do it right up here. So I'm going to take the f of x out. I'm replacing it with what it's equal to, which is 5. And then I'm going to solve this problem. I didn't mean to switch colors there. Subtract 5, trying to get x by itself. 0 equals 2x. Keep solving, you're not done. Divide by 2, x equals 0. Okay? Okay, domain is all the possible inputs, but they didn't give us a list of those. Well, is there anything we couldn't plug in for this x? I think I could plug in any number I want. Positive, negative, fraction, decimal. I could always multiply by 2 and add 5. So any number will work. So we call that all real numbers. And the symbol for that is a capital R, but with 2 legs there. Okay, so capital R, but you put an extra leg. So draw 2 lines, then make the rest of the R. One year I had students keep saying this meant IR. That's not IR. It's not IR. I don't know if that's crazy talk. It's a capital fancy R that's just got an extra leg there. Range. Excuse me. Is there anything when you plug a number in that you wouldn't get? No. If I can plug every number in, I could get really big numbers, really small numbers, decimals, fractions. So the range is also that. When am I going to get a domain that's not all real numbers? Remember, I think it was unit 2, maybe section 2.4, where we had problems that look like this that you had to solve. And we talked about excluded values. What would be the excluded value here? Well, it would happen when x plus 5, we could say that can equal 0. So we'd subtract negative 5. So x could not equal negative 5. So we could not have a domain of all real numbers here because x doesn't equal negative 5. So that would be something that would not be in the domain. So that's how you come up with that, how you come up with things not in the domain. All right, number 4, we've got a mapping. What does f of negative 2 equal? What's it map to? Negative 5. Solve for x. If f of x equals negative 27, so this is the output. What's the input for your x value in this function when y equals negative 27? There isn't one. Look, nothing maps to it. No solution. Domain. Well, you've got more things listed than are actually in your domain. Your domain are only things that get mapped. So just negative 2 and just 12. The range, just things that are mapped to in order, numerical order, negative 5 and 3. The 0 and the negative 27 never get mapped to. Is this a function? Sure is. Not. Said the wrong thing there. It is not a function. This 12, this x, has 2 different y's. Each x can only have one y. Okay, this is not a function. We forgot to say if this one was a function, and yes, it is. Think about what this graph would look like. It'd just be a nice straight line. And we'll see later, all straight lines, except for one, are functions. Okay, let's try another one. F of negative 2, so that means we are plugging negative 2 in. So f of negative 2 equals negative 2 squared. If you do not use parentheses here, you will get it wrong, because keep in mind, negative 2 squared this way is negative 4. But negative 2 squared this way is positive 4. Why? Well, because this one would be a negative, and then 2 times 2. You only square the number. But this one, you're squaring the negative sign as well because it's in parentheses. So that would become a positive. So we've got f of negative 2 equals 4 plus 1. So f of negative 2 must equal 5. Input negative 2, output 5. This time they've given us an output of 101. We want to know what the heck did we plug in to get 101. So f of x equals 101. I'm going to put 101 in the f of x spot. Let me write the whole thing down here, actually. So my problem, f of x equals x squared plus 1. Because they've given us the output, I'm replacing the whole f of x with it, not just the x. That's not your x. That is, in fact, your y. Solve by subtracting 1. 100 equals x squared. And then how would we get rid of the square? Or what number squared equals 100? You could either take the square root, or you can think just what number do I square to get 100? And hopefully you're thinking 10. But that's not the only one. Because remember up here, if I put a number in parentheses and square it, a negative number, it becomes positive. So we could also have negative 10. Is this a function? Can you think of any two numbers that you could plug in and get the same answer? That would be okay. I could plug in negative 2 and plug in 2. I'm going to get the same answer. But those are two different inputs. We don't care if they have the same output. Is there any number you could plug in and get two different answers? No, that's not going to happen. So this is a function. What's the domain? Is there anything you couldn't plug in for the x? Can you plug in negatives? Yes, we already did. Positives? Sure. 0? Sure. Anything you couldn't plug in? Fractions, decimals? No. All real numbers then. But think about your range here. Look at what happened when we plugged a negative number in. We got a positive. What would happen if we plugged a positive number in? We'd still get a positive. Could we ever get a negative out of here? Nope. The smallest value we could get out of here is 1. Because if I plug a negative, say negative 2, and look, I'm bigger than 1. Any negative number is going to give me something plus 1, a positive number plus 1. 0 would just be 0. 0 squared is 0. Plus 1 would be 1. And positives are going to give me bigger. So we would say that your range, your y value, is going to be greater than or equal to 1. And if you're not 100% okay with that, if that's a little confusing, don't worry. Not the biggest deal. Not going to be on your mastery check. All right, pause the video. I want you guys to do number 6. Don't forget to tell me whether it's a function or not. Okay, this is definitely a function. Each x value goes to just one y value. You've got a y value, a couple y values that have more than one input, but that's okay because remember, we just need to make sure every item has one y value. Each x can only have one y value. Each item at the store can only have one price. But it's okay if two items cost the same amount. F of 11 equals 3. Hopefully you got that. When does x equal, when do you get an output of 2? Well, I don't think you get one. 2 is not even an option here. Domain in numerical order, -5, 0, 11, and 14. And your range in numerical order, just 0 and 3. Those are the only two that get mapped to. Okay, some more work with function notation. I know the video is getting a little long. It's a lot of stuff in here, but we're almost there. All right, so more of what we've been doing, right? So these numbers in the parentheses, those are your inputs. So we're simply going to plug them in to our functions. Now we've got two. We've got an f of x and a g of x, and they just do that because we need two different names. This one's Fred, this one's Gary. F is this one's name, G is that one's name. That's all it is. So f of 5 is just saying, hey, take your f of x function, just rewrote it, same exact thing, and f of 5 means take 5 and replace your x. You're substituting 5 in place of the x. Well, that would be f of 5, I don't need to keep rewriting, I can just make an equal sign. 3 times 25 plus 2, which would be 75 plus 2, so we get 77. Okay, I'm going to skip the next one for a second. Looking at C, well, oh no, I'm not. I'm going to do g of 3. G of x is 2 to the x power. Just rewrote that again so I can work right underneath it. G of 3 means put a 3 in place of the x. 2 to the third power. Don't say 6. 8. 2 times 2 times 2. F of 5 plus g of 3 means find f of 5, find g of 3, add them together. But look, we found f of 5. It was 77. Why do that work again? We found g of 3. It was 8. Don't do the work again. It's already there. 77 plus 8, 85. Okay? I'm going to skip D for a second, go down to E. Sometimes what they ask you to plug in isn't a single number, it's a whole expression. That's okay, we can do that. So f of x is 3x squared plus 2. So f of y plus 2 means I'm going to take the x out and I'm going to replace it with y plus 2. Use parentheses. Because look, I have to square y plus 2. Keep in mind, you cannot just distribute the square. That never works when you have a polynomial, more than one thing in here. So we've got to take y plus 2, write it twice, remember this, and multiply it all out. I'm going to leave the 3 for a second, because this is all multiplication between those two things and these two things, and we don't care what order we multiply in. So I'm going to choose to do this part first. So we get y times y is y squared, plus 2y, plus 2y, plus 4. And then drop down the plus 2. Keep working there. I'm going to now combine my like terms inside my parentheses. So I get 4y from right here. Now I'm going to distribute the 3, and it's going to 3 different things. And then tack on my plus 2. Don't forget about that. Keep dropping that down. Finally, combine like terms at the end. And I get plus 14. Now notice I'm not getting a single number for my answer. But hey, that's okay. I didn't have a single number to plug in. I had an expression, so I get an expression out. Okay? Pause the video. I want you guys to do D, F, and G. Pause the video. Okay, f of 2, you plug 2 into the f function. 2 squared is 4, 4 times 3 is 12, 12 plus 2, 14. And then plug 1 into the g function. Well, 2 to the first power is just 2, so you should have got 16 there. G of n minus 3, remember, you're just taking the x out and replacing it with n minus 3, and that's all you can do. You can't simplify that any further. And then finally, g of m equals 32. So they've given you the output. So 32 is equal to 2 to the x. Solve for the x. What did you guys get? 2 to what power gives you 32? And hopefully you got a 5 there. All right, last thing. Mr. Brust is selling Algebro t-shirts from his classroom to raise money for ankle warmers. That sounds fun. For each t-shirt sold, Mr. Brust makes a profit of $5. Let the function b of t equals 5t represent this scenario, because he's making $5 for every shirt, 5 times t. Well, what would b of 3 mean? Is 3 your input or your output in that notation? That's your input. So 3 is equal to your t. What's t stand for? Number of t-shirts. So that means 3 t-shirts sold. Describe what b of t equals 20 means. Well, 20 here, that's your output this time. So what would 20 mean for your output? That means he had a profit, or he made a profit of $20. What's a reasonable domain in this context? In other words, what could your inputs be? And when I think that, I always think, what could my inputs not be? We're talking about your inputs, being your T. T is the number of t-shirts sold. Well, we can't have negatives. That won't work. We're not going to sell negative number of t-shirts. What else couldn't you have? Can't sell decimals or fractions of a t-shirt. So a reasonable domain, well, it would have to be like 0, no shirts, or 1 shirt, or 2 shirt, or 3 shirts, or 4 shirts. I don't know. I don't know how many he's going to sell, so I'm just going to leave it like that. Another way to say this, non-negative, because we know we can't have negatives, but we could have 0. So we don't want to just say positive because 0 is neither. So non-negative includes 0 and all your positives. Whole numbers. And in fact, when you say whole numbers, that means just 0, 1, 2, 3, 4. So you really could have just said whole numbers. But I don't know if you remember that vocabulary, so you could list them out just like that. Certainly not all real numbers, though, because we can't have decimals, fractions, or negatives. A reasonable range, well, if he sells no t-shirts, 0 t-shirts, he's not making any money. So if I plug 0 in, I'm getting 0 out. If I plug 1 in, if I sell 1 t-shirt, or he sells 1 t-shirt, $5. 10, 15, 20, etc. And we could just follow that pattern. So that would work just like that. And one more thing to add, we really should have given variables here. So t would equal, and then over here, for your range, you're talking b of t. I know this video is a little long. Sorry, guys, a lot to get through there, but keep chugging along. Work on those problems.